Hi, I'd like to do a quick demo on using the Virtual Vulcan software. What I have here right now is a open window with the Virtual Vulcan, and what I want to do is I'm going to work on a simple A times B, A and B circuit. First of all, we need to just understand some of the parts that you see here. Off to the left, you'll see some switches. 8, 9, 10 switches. The first switch is the master on and off. The next 9 are switches for your letters A, B, C, D up through 9 letters. The software is set up so that when these are down, your switches are off. When this is up, the main power is off. Next thing I'd like to do is point out your ground and power. Over here is your grounding hole. There's 2 of them. And right next to it is your power hole. There's 2 of those as well. Next thing are your switches. I have 8 switches that I can work with. 2 holes for each switch. And in this area is where I have my outputs. I can have up to 8 outputs. In most cases we are only doing 1 output, so you can pick any one of those that you would like. So let's make an A and B circuit. Step 1. Let's make sure we get the right circuit chip. If I go up the word chips, click once, you will see a whole bunch of different chips available. In your paper assignment that we've done earlier, you'll notice that we want to do a 7408 quad 2 input. Sounds like a lot, but let's just click on it and show you what it can do. So I click on that, and now I have a AND chip. If in doubt, if you right click on the chip itself, or double click on the chip itself, it will give you a diagram of how this chip is laid out. Top left hole is for power, and then 2 inputs, 1 output. 2 inputs, 1 output. 2 inputs, 1 output, 2 inputs, 1 output, and then you have your ground. It's called the quad AND chip because there's 4 AND symbols built into it. First thing I want to do is power up this chip. What I like to do is put a power wire from my power supply to the top row. I have now made the entire top row a power row. I know that this first pin on my chip is the power chip or power pin. So since all of these are connected, I just need to get power from one of these holes to the top chip, or top hole. I have power, but I don't have ground. So the next step here is to ground my chip. What I like to do is start my ground and put it on one of the bottom rows. If it'll let me. Now I must ground my chip. Here are all my grounding pins. All those are connected, so I just need to make sure one of those connects to my ground pin as well. Basically, I've done my prep work. I've got the chip I need, I've powered it, I have grounded it. Now comes time to build A times B Boolean. Well, again, if I look at my chip, the next 2 holes are inputs followed by an output. Input followed by output, and so on and so on. I can pick any one of these that I want. I'm going to use these 3 pins right here. Input, input, output. So I want A times B. So I'm going to grab one of these and call it A. I'll call this A right here. And I need to make sure it gets into the input. The input is any one of these holes since they're all connected underneath. The next thing I need to do is to get B inputted into the next row of holes. So I'm going to take B and put it in to the next row. I have A going into one input, I have B going into the other input. The last and final thing is to make my output do something. I'm going to take this output, any one of these holes, and connect it to an output hole up above. Well, it's time to check. A times B. When both switches are off, I should get no light. When one is on, the other is off, I should get no light. When they are both on, I should get an output of 1, or a light. So here I go. Turn on the master power. That tells me that it's working. Next step is to flip the switches on or off. A is in the 8th spot, so A is the 8th switch. Flick it on, flick it off. Nothing happens. Switch B is in the 7th slot. As I flick it on and off, nothing happens. But if I flick them both on, I get an output. Yay me! That's what's supposed to happen. We have built an A times B circuit. Now if I wanted to build an A plus B circuit, I can literally take 7408, delete that chip, go up to chips, and get the right chip that I need for the OR, and plop it down right there. Hopefully this helps. Let me know and keep me in touch.